All right, so it says determine the lengths of both sides of the rectangle. Give the answers. Oh, okay. So the issue here is setting it up. All right. So let me take a screenshot of this and then we'll plug it into the notes. So here's the thing. This is an application of the concept itself. So I'll put this in the Jamboard notes too, so you can refer to it later. It's a lot of work to get to these Jamboard notes. All right. So this is problem number 10 from the homework. And it says determine the lengths of a rectangle using the given area, given the answers, blah, 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 blah. Right? So this is, we're working with quadratics. So they said, and I'm going to ask you some questions, and I ask you the questions, you're going to be like, oh, okay. What information do we know? Well, it says the question is determine the lengths of the sides of the rectangle using the given area. I'm going to underline the word area. That's a clue. Give the answers both exactly and approximately to the nearest tenth. Now, what that means is you're probably going to have a fraction. So whenever they say exact, that's going to be some sort of ratio, which you guys most commonly refer to as a fraction. Or it'll be like pi. Or it'll be pi or some like a square root or something like that. So when they say exact, that means don't essentially exactly means not a decimal. So you're going to solve this thing and get x equals something. And whatever that x equals, you just leave it. And then when they want the decimal approximation, you plug that in the calculator and then you round. Okay. So they say that this side length is x. Well, if that side length is x, then this is x. And we'll just call that the width. And we'll call this the length. Okay. So when you get to this, one thing I want to point out is that we actually went over an example like this in class. I think it was example 6. Now, we only went over it one time, so you probably don't remember it, and that's okay. But I know in one of the classes I went over, they do the dimensions of a pizza box. All right, so it was available to you. So let me find that example.
Okay, so it says solve quadratic equation given.
Maybe it was 4. Of course, my thing would take a long time loading.
Okay, so for this one, basically what we're going to end up doing when we go to do these problems is we're going to get...
I think it's this one.
So anyways, on this one, it says a square field is enlarged by adding 5 feet to the length and the width of the original field. If area it...
And so this is a very similar scenario, and the video is only 4 minutes long, but essentially, and I'm going to just fast forward through the video. What they're doing is we're using this thing, the area of a rectangular shape, and then we're doing some algebra. So the setup is very similar, okay? Very similar. And if I go, and I'm not going to show the whole video, but basically Mr. Adams sketched out a box and said that the area of a rectangular shape is L times W. Now this one is a square rectangle, right? So that's a square. So because they're the same length, you would say S times S. But this is a length and a width, right? And so it's rectangular, except this is actually a square. So that example was there, okay? But if we go back, shoot, I closed the Jamboard notes like a goofball. So we're going to do the same thing here, right? They give us the area, so then the area, and now I know next time I'm just going to do all the examples. It might save you a little bit of time. Length times width. Well, what's the length? Well, I said that the length was 2x, right? And what's the width? Just x, okay? Also, they said the area of the rectangle is 54. So I've got 54 is equal to, what's 2x times x? Does anybody know? No, you're multiplying. Yep, 2x squared. Hey, that's quadratic. So now what do I do to solve this? Divide by 2. And you're going to get x. I'm going to just toss this over here. Well, let me scroll down. So you get 27 is equal to x squared, right? Because the 2's cancel. Boop, boop. Now what? Yeah, so we're going to take the square root of both sides. We're going to take the square root of both sides. Square root of x squared is just x. And then you could think of the square root of 27. 9 times 3 is the same as 27. Now remember, when we have a big number under the square root symbol, to simplify a square root, we think is it divisible by 4 or 9 or 16, and so on and so forth. Those are called what we call perfect squares. My daughter doesn't say perfect anymore. She says perf. It's a little weird. Okay. So then I can, by the properties of radicals or square roots, I can separate it like this. And so then what's the square root of 9? 3 and 3. So we get x is equal to 3 root 3. Now, because we're doing the square root, I forgot to mention this needs to be plus or minus. Technically, this is plus or minus. So this is plus or minus. But we're talking about the length of the box. So we wouldn't use the negative symbol, right? So the negative is extraneous. So the exact thing means that we're going to leave it as this. So the width, we said, was just x. And we said that, and we're going to use what we call the principal root, root 3. So it's 3 root 3. So in here, we're going to say root 3 root 3 And the exact length, remember that the length is 2 times x, or 2 times root 3, or 3 root 3. So here, you just take the 2 and multiply it by 3, and you get 6 root 3. So you could say 6 root 3. Okay. Then to do the decimal approximation, you just plug it into the calculator, right? So I say 3 square root of 3. And, you know, if you're not sure if you did your simplification of the square root, you could take the square root of 27. It should be the same, right? So that's rounding to the nearest tenth. So what's the nearest tenth on that? 5.2, right? Remember, this is the 10th spot right here. So, and you look directly next to the 1. So, so it equals 5.19, a bunch of other numbers, right? So when you round it, this is the 10th spot. So you look at the number to the right of that. If it's greater than 5, you round up. So it's approximately 5.2. So the width is about 5.2 centimeters. Now for the length, you're just going to multiply that number by 2. So I'm just going to take my answer, multiply it by 2, and I get 10.39 roughly. So same thing here. I'm going to get 10.39 ... That keeps going. 3 is what I'm rounding to. That's the 10th spot. So I look at this number. It's greater than 5, so I round up. So that is approximately 10.4. And I think you guys might have different numbers or whatever. Okay. So when you go to do your homework and it says it wants the exact value, how could you look that up? So before we started recording, there were some things. So we know the area of rectangle, right? So if you didn't remember the formula, there it is. Length times width. If you didn't know, so these are the concepts, right? So it says exact value. Here's a 18-second video. Let's see what he says. Oh, he signs it. We'll just click on this and see how long it takes us. Oh, he's just signing it. Definition. Let's click on the definition. Exact values where you can approximate 5. Yeah, so that one isn't as helpful. But in your textbook, let's pull up your textbook. I think that might be a little more helpful. So when you look in your textbook, it is in the context of what you're doing, right? So we're working on quadratics. We're working on 3.1. When we look in the lesson, if I were to look for exact example number 2, it says give an exact answer, and if it's a decimal thing. So I guess on that one, you just have to ask Mr. Adams because it's not very clear what an exact value is. Were there any other terms or questions that you guys didn't quite get? Yes.
Yeah. When we get the square root of 27.
Yeah.
9 times 3 square root. How do we get that?
Okay, so I'm going to end the video and we'll talk about that in just a second, okay?